In this video, we're going to look at integrating this particular function. We have x over the square root of x squared minus 6x plus 5. If we try our traditional u substitution, that's not going to work. So maybe what we want to do first is complete the square of that denominator and see what we're looking at. We've been doing trigonometric substitution, so that may be what it is. So let's go ahead and complete that square. So x squared minus 6x. Then we got to figure out what we need to add and subtract. So the linear coefficient is minus 6. Divide that by 2 becomes minus 3, and then we'll square it. So we're going to add 9 and subtract 9, so we don't change anything. Then the first three terms makes x minus 3 squared when we factor, and then we have minus 4, which we'll write as minus 2 squared, so we can see if it fits one of the particular substitutions using one of the forms we do, trig substitutions. And this looks like it's probably going to be the u squared minus a squared variety. So the u squared minus a squared variety, and so when we set that up, we had something like this: u, a, and then u squared minus a squared. And so that's the setup we're looking at here for this trigonometric substitution. And so let's go ahead and do that with our specific problem. The hypotenuse is going to be x minus 3. And we'll want this side to be the constant of 2, and then using the Pythagorean theorem, that'll give us that other side right there. So we'll go ahead and put that in, and then we're just going to write down some stuff, put in our angle theta, and so we are aiming to replace everything that has an x. So there's an x in the numerator. You got an x minus 3 squared minus 2 squared, all under the square root. We're going to look to try to get rid of that. And we also need to substitute for the dx. So all of the x terms need to be replaced with something in terms of theta. So the way this one is set up, it's we want to get that x minus 3 in there somehow so that we can get our dx. So secant of theta is the hypotenuse over the adjacent side, and then we'll multiply by 2. Well, 2 secant of theta is equal to that x minus 3, so that's a little bit nicer. Now we'll go ahead and differentiate, and we have 2 secant theta tangent theta d theta is equal to dx. Okay, and that's going to be one of our things we need to substitute, so we needed to substitute in there for the dx. Okay, and this second equation here, that's going to allow us to solve for that x that we need to solve. We need to replace. So we're going to solve that for x. So 2 secants of theta plus 3, and that's going to be equal to x. Okay, so that's one of the other things we need to replace. And the last thing is we need to swap out this whole denominator here. And the tangent, the opposite over the adjacent, will probably do the best for us. So we'll have not 2 tangent yet, but tangent of theta is equal to that square root business all over 2, and then we'll multiply by 2, so then we'll have a nice clean substitution. Okay. And so those three things boxed in there, that's what we're going to substitute into our integral here. So let's go ahead and do that. So the x becomes 2 secant theta minus, I'm sorry, so minus 3? No, it's plus 3. Okay, that's all right. The dx is 2 secant theta tangent theta d theta. And the denominator is 2 tangents of theta. Oops, let's go back. Hold on. Now what we have is everything is factored here. So this 2 tan theta will absorb this tan theta and this 2 here. And then what we'll be able to do is distribute that secant through. And what we'll have is we'll have a secant squared and a secant, and we know how to find the antiderivatives of both of that. So we're in business now. Okay, so let's go ahead and write that all out again. So this is what we got going on. Okay, so that 2 tan of theta is going to be able to divide out with some of the stuff in the numerator. And so what we'll have left is 2 secant squared plus, and it's not 6, it should be 3. So let's make sure we make that a 3 there. Okay. Alright. And we know that the derivative of tangent is secant squared, so the antiderivative of secant squared is going to be tangent, and the antiderivative of secant of theta is going to be a little bit trickier. You just got to get a little bit of practice. But the antiderivative of secant is secant, not secant, it is ln absolute value secant plus tangent. Okay, so let's keep going. So antiderivative of the secant squared will be tangent plus, and it's not 6, it is 3 ln absolute value secant theta plus tangent theta plus your constant of integration. Okay, let's go ahead and put in our reference triangle to go ahead and do all that substitution business. Okay. So the tangent is going to be the opposite over the adjacent, so we'll go ahead and substitute that in. So square root business all over 2 plus, not 6, it's 3. Ln absolute value. And this time the secant is going to be the hypotenuse over the adjacent side, so x minus 3 over 2. And then we got tangent of theta again, plus constant of integration. And then maybe you're looking at my solutions on the answer key, and you know, we found the antiderivative. I did some simplification here. So we have these twos are going to absorb. We got a common denominator here, and then I also am going to use the quotient rule for logarithms, so we'll see where that plays in just a second here. Alright, so go ahead and expand that out. Now, I guess it technically doesn't really matter, you can leave it kind of factored, but we're going to revert back to what the radical expression was when we first got it. Plus 3 ln, and then what we're going to do is they have a common denominator there, so we're just going to write them over the common denominator, and then plus c, and we're just going to use the quotient rule for logarithms, so ln of a over b is going to be the ln of a minus the ln of b, and if we have a 3 out in front, then the 3 just follows the factors there. Okay, so that's what's going to go on here, and you're going to have a minus 3 ln of 2, and, well, that's just a constant, so that's going to be gobbled up by the constant of integration. Okay, so go ahead and write that all out. Okay, and then there's your minus 3 ln of 2, and it's just a constant, so what we can do is combine those, and you can call it a new constant if you want. You can call it c star or whatever, but it's just a constant of integration, so that c is going to gobble up that constant of negative 3 ln of 2, and we can call it an orange c if you like, and that is going to be your antiderivative.